But I really wanted to spend a moment and just fancy how nice this shirt would look on me instead of the spring one. This is one of the better shirts, and I regret that I have not worn this one instead. So if you have your shirt, wear it with pride. This has been a really cool show. Do you think this has been a great show? Heck yeah, right? Bravissimo. Good stuff. Vox Days, Bucharest. What a privilege. So I am super, super happy to be here. Thanks for that. If you could file in nice and quietly, have a seat, join us. It'll be fun. Let's see. Whilst we're doing that, can I get you all, please, to say open source on my cue? Okay. Ready? 1, 2, open source. Open source. Oh, that's so money. Good stuff. Thank you. Right on. So, my friends, we have so much to cover until very little time. It's now 9 after, so I have 50 minutes. So 30 after, we have to finish, I guess. A little bit about me. We're going to go through code, first of all. Actually, I suppose I should mention that. We have a lot of code to go through. I hope you can see that code there in the back, my friends. It's going to be awkward if you can't see it. So you may want to take down the URL for what we're going to look at here. Note that, take a photo, follow along later. Not now. Whatever you do, don't do it now, okay? A little bit about me. My name is Josh Long. Thank you for coming. I'm on the internet, and I'm always happy to hear from you. If you're on the internet and you want to carry this discussion forward, please don't hesitate to reach out to me. I'm at StarbucksMan on Twitter. How many of you are on Twitter? Twitter. Good stuff. 2016. We're all on Twitter. Right on. What about email? Email. How many of you are on email? Okay. That's the old social network that we used to use. So if you're on either of those social networks, the email and Twitter, please reach out to me. I'm here at your service. I am the Spring Developer Advocate at Pivotal on the Spring team. I'm the lead author now of going on 5 books, co-contributor to lots of different projects. I'm the leading contributor of bugs. Leading contributor of bugs to projects like Spring Boot and Spring Cloud, Vaadin Activity, Spring Integration, and Spring Batch. I'm just very, very lucky because I spend my time helping organizations, customers, community, etc., move software quickly and safely to production. That's what we all do at Pivotal. How many of you have heard of Pivotal? Pivotal's we're a small company. We started in 2013. It's where Spring lives, right? Lots of great open source. So how many of you heard of Spring? Spring. Okay, good stuff. What about Apache Tomcat? Tomcat. Yeah? No one. Okay. Right on. What about Cloud Foundry? Anybody here know of Cloud Foundry? So Cloud Foundry is an open source platform as a service. It's a platform for building applications. It's optimized for the safe and continuous delivery of applications into production. We care about that, right? Because today we see that organizations everywhere are struggling to go faster. They're struggling to be able to deliver software into production where the users can use that software, right? And this is very important. We see all over the place that software-first organizations are the ones that are able to disrupt, that word, disrupt other verticals, other industries. So right now, what is the largest taxi company in the world? Uber, right? Exactly. What's the largest video rental service in the world? Netflix, exactly. What's the largest car company in terms of year-over-year growth? Tesla, right? These are software-first organizations. What's the largest hotel company? Airbnb, exactly, right? So we have a place now where we're seeing that something like 75% to 80% of the companies that were on the Fortune 100 in the 90s are all gone. It's all new software-based companies, right? These are companies that are delivering software faster, the only way to succeed is to go faster in delivering new ideas. And so organizations struggle with this. They have a lot of hard trouble trying to get ideas from concept all the way to production. And they look for ways to go faster. In a typical organization, you've got the software, you've got the product management, you've got the user experience people, you have the developers, you have the testers, and then the various administrators. This is the workflow of various organizations, the software factory. Work goes from one station, then it waits for the people to be available in the next station, and then they process it, and then it goes to the next one. But there's queuing in between each station. This queuing means that if I have an idea in product management, even though it may only take a day here or a few days or a week or whatever in each station, even though in total, in terms of actual time spent at each station, maybe it's 2 weeks. But the result can actually be months for some organizations, or worse, right? Before they can actually see those ideas in production. The clock time is very different from the actual time. This means that if you have a chance to make a decision to respond to something that the market is doing, you can't wait months, right? That's a very, very bad way it's a good way to fail. It's a bad way to win, right? So you need to go faster, and organizations struggle with this. One thing they can do to go faster is by embracing cloud computing. They automate as much as possible. The administration at the end, the networking, the database administration, the SAN administration, all of this stuff becomes something that gets part of the cloud computing platform. Cloud computing gives us the ability to go faster, and it makes all of that extra work at the end go away. Great, but we still have all of these queues in between the original few stations. Another thing that organizations do is they take these large applications, these large monolithic code bases, divide them into small pieces. They look for what is called a bounded context. A bounded context, if you've ever read Dr. Eric Evans' amazing tome, Domain-Driven Design, a bounded context is a part of the application and the domain that is internally consistent. It stands on its own. It doesn't need this to be viable. And if you can find and isolate those bounded contexts, you have something that is small and that a small group of people can work on without waiting for another group of people. If you have a large code base and you have a lot of people working on the same code, then you have to wait for them to finish their changes before you can integrate code and stabilize it and then deploy it. By finding these small batches of work, by finding these small bounded contexts, we can separate the work streams, separate the products. Small groups of people can focus on one small piece of functionality. We call this a feature team, right? Netflix and Amazon have done this. They've created teams that are small enough that they can be fed with 2 pizza boxes. They call these 2 pizza box teams, right? Right? Yeah, really. The idea is that the cost of synchronization in your head on the team is expensive. If I have to wait for people in different time zones and I have 20 different people in other parts of the world, or even just too many people in my same team in the same office, there's a cost to state synchronization in the brain. Getting rid of that, making it so that you can go around the loop, have an idea, write the code, get the test, see the result as quick as possible, is very important. It creates flow. It gives us the ability to create ideas and see them developed delivered into production faster. So we love that, right? At Pivotal, we care about that. When you move to this architecture where you create small batches of work and you deploy them independently of each other, you're using network boundaries as the interface between these components. You've moved very squarely into the camp of distributed systems. And if there's one thing that we all know, application development and distributed systems is hard, right? Very painful. There's a lot of non-functional requirements that come with this move. So what we're going to look at today are 2 things very, very quickly. And I want to restate, the goal today is not to remember everything that I'm going to do. The goal today is to know that it's possible and look at the details later. We're going to go through a lot. I mean, a crazy lot, right? My goal is just to show you all these things that are out there and so you can see what's possible. There are great resources to learn more on the intertubes, right? So start.spring.io, spring.io/guides. Have you seen these? These are spring.io/guides. These are a great place to learn all about different types of technologies and so on. So if you want a guide on if you want a guide on how to build a REST API or how to use service registration or discovery or talk to a database or whatever, these guides are 10 to 15 minutes long. No assumptions. Everything is spelled out in nauseating detail. You should have what you need right there very quickly. Now, so keep that in mind for later on, okay? Now, we're going to build a simple application, a simple REST API. We're going to build a simple REST API, not to show how to build a REST API, but I want to have something to talk about, right? So we're going to go here, go to start.spring.io. Now, this is my favorite place on the internet after production. So production, and then start.spring.io. If you are sleepy and want energy, want enthusiasm and inspiration, start.spring.io. If you have heartburn and need relief, indigestion, start.spring.io. If your children can't sleep and you need relief and you need help, start.spring.io. Keep this bookmarked, keep it under your pillow. It's my favorite place on the internet, like I say. Now, what we're going to do is we're going to go here and build a simple application. I'm going to build a new service called the reservation service. I'm going to choose to build a web application. I'm going to choose to use the H2 in-memory embedded database. I'm going to use JPA, the Java Persistence API, because I make bad life decisions. So JPA. I'm going to use Actuator. I'm going to use REST repositories. I'm going to use Zipkin for distributed tracing. I'm going to use Stream Redis processing, right? Using messaging for integration. There's that. I'm going to use the config client. I'm going to use Eureka Service Discovery. And that'll be enough for now. This is just, we have got 6 more to go, so relax. Now, again, you have choices here as well that we didn't look at. I could have chosen to show the full version and then manually add these options here. These are checkboxes for other technologies that we can support with Spring Boot and Spring Cloud. You can see here that I've got choice about which version of the language I want to use, Java 1.8, 1.6, or 1.7. Use 1.8, okay, good. You can choose a version of the language that you want, Java, Groovy, Kotlin, whatever you want, it's all fine, it's all good. And then of course here, my friends, here we have the ultimate conflict. If by some accident you are stuck in the distant, distant past, unable to move forward to the future, which is today, so it's not really all that impressive, then by all means, choose .war. But if you're here with me today, in 2016, then choose .jar. Now this is a big part of my personal philosophy of make jar, not war. And again, you have options. You have options. I want you to do what is right for you, okay? Please do you. It's okay. Now, we've made our decisions. I've got a little zip file here. I'm going to open this up in my IDE, and I'm going to build a simple application very, very quickly. We're going to build a REST API, and I need to have some dummy data. So you can use whatever you want. Here we go. Allow. Oh, okay, good stuff. Let's load this load. Here we are. Now, reservation application. I need to store some data in the database, so I'll create an entity of type reservation. By the way, can you see that font? Should I make it larger? Is it too small? In the back, can you see it? No? Oh boy, okay. See, I've already got it at more bigger. I don't know how to make it more bigger. Let's see, 24. What about that? Well, 6? Okay. Sweet nectar. Good stuff. So I've got, you can read that? Okay. I'm going to create a simple JPA entity. I'll say @entity. There we are. I'm going to create a private primary key called private long ID. I'm going to create a field called reservation name. And this is just an object of type reservations that we're going to store in the database. Now, I'm going to also give it a surrogate primary key and auto-incrementing value, so I'll use JPA there. And this is Java, of course, so some getters and a constructor and another constructor for JPA, right? There's that. and then a toString method as well. There we go. Okay, so now I'm gonna store some data in the database, and I need to handle the boilerplate creation, reading, updating, and deleting that comes with working with an underlying persistence tier. So I'm going to use Spring Data Repository support. This is the JPA repository. There's equivalent support for MongoDB, Cassandra, Neo4j, Couchbase, etc. This is not it's not a abstraction that's common to all of them. You get the best of breed features from each of them. It's not a minimum viable, common abstraction, right? You can see that these repositories support CRUD. So find all, delete, save, all this kind of stuff. And you can also define custom finder methods. So I can say, custom finder method that says collection of reservation, find by reservation name, string rn, okay? There's this. And I'm going to expose this as a REST endpoint, right? So I want to say REST resource, path equals by name, and I'll say at param, and I'll say rn. I'm going to say at REST repository resource. There we go. And that'll give me a REST endpoint that I can actually access this data with. And I don't want to spend too much time on this. I do need to create some simple sample data. So I'm going to say dummy CLR implements command line runner. Okay, and this is a callback interface. I'm going to say to Spring, when this bean gets called, when this bean is created, when the application is started, call this run method and pass the public static void main args as the parameter here. Okay, and this is just a simple object that I'm going to create just to store some simple sample data. So I'm going to use the repository. We don't have to define the implementation after all. And I'm going to say stream, hello computer, stream dot of my friend Costin, Josh, Mark. Who else wants to be? What's your name, sir? How do you spell it? A-L-I-N. Like that? Cool. You, what's your name? How do you spell it? N-A? M-A? D? A? Like that, like I? Like that? Whew. Thank you. For each name, I'm going to store some data in the database. And we're going to, write it out like that, and there we go. And I'll do this as well. I'll say for each one, let's print out the information. Okay, so there's all that, and this is fine, right? I've got the data here. It's gonna work when the application starts up. I've got a lot of things on the class path, so let's go ahead and just take a look at that. These dependencies correspond to the starter checkboxes on start.spring.io. These are opinionated dependencies, so I'm going to leave them in here for now, but just keep in mind that there's a lot of stuff there, okay? Now, I'm going to restart this, and we should, if everything has gone to plan, have a REST API with our information in it that we can talk to from the client, right? So here we go. Okay, come on, computer. There we go. Good stuff. So that worked. There it is. Look at that. Of course that worked. This is a demo. What do you expect? Instead, I really wanted to talk about this. This is the ASCII artwork in Spring Boot. Now, the ASCII artwork took a lot of really smart people a lot of time to get right, but look at that. Absolutely gorgeous. I want to just say that I have one complaint about IntelliJ. I like the product. It's good stuff, but what the hell? What's that? Why is that there? That's a dumb feature, and I think we should get rid of it. Anyway, moving on. So we have an application, localhost 8080/reservations, right? There's our data. Now, we're going to build a distributed system, right? So this is a simple service, but I want to be able to customize this application. This is working so far. By the way, notice that we have reservations. These are the payloads, and there's links. These links are hypermedia. It's an implementation of the design pattern HotOS. Hypermedia is the engine of application state. The idea is that every REST resource should have information in the response so that the client can use the REST resource without having to read the documentation, basically, right? No a priori knowledge. This is very, very valuable because it means you have self-describing REST services. Now, later on, keep in mind that this is using Spring Data REST, which in turn uses Spring HotOS, okay, HotOS. So keep that in mind in the back of your head for later. Now, I can run this application. I can customize it by going to application.properties, and I can say server.port equals 8000, for example. But I don't want to have to recompile the application every single time I change a property. I want to be able to externalize this configuration from the application and keep it separate from the compiled code. So if you know about Spring Boot, how many of you have used Spring Boot? Okay, good stuff. So you know that Spring Boot normalizes configuration for a lot of different things. Hello, computer. Oh, that's the old, okay, that's fine. Let's kill some stuff here. While that's doing that, downloads, reservation service. We'll do maven -d skip tests equals true, clean install, YOLO. Okay, Zipkin, run that again. Sweet nectar, good stuff. So there's this target, and I can do, for example, java -jar reservation service.jar. I can do -d server.port equals 8010. Right? Instead of, that way I don't have to compile the jar again. I don't have to change the property file. I can also do export server underscore port equals 8020, right? And then do java -jar. And so there we get the application, the good quality ASCII artwork, and you get the new port, right? So, hello, wait. Oh, too fast. There it is. So there's my new port, right? 8020. Right? It's using the environment variable. So that's called 12-factor style configuration. But 12-factor style configuration just means that you externalize the configuration. This is okay, but it doesn't work in a number of scenarios. First of all, if I have a lot of different services, I want to be able to centralize and manage all of my configuration. I don't want to have to revisit every startup script or every shell script that I use to start my applications and change environment variables. I want to be able to keep it in one place. Second of all, how do I change configuration variables live without restarting processes? If I have an environment variable, I have to change the environment variable and then restart the process. That's not very useful, right? It's very hard to maintain. Also, if I have sensitive information, I need to be able to encrypt passwords and decrypt them live, right? Also, I want to be able to see who made changes, right? So if I go out into this beautiful city and get maybe have a little too much to drink, and then I go into production and I start making changes, I want to be able to see that Josh was in Bucharest and that something is wrong and I need to roll back the changes. How do I support auditing and traceability, right? For these use cases and more, this isn't going to work. I need something a little bit more mature. So what I'm going to do is build a config server. The config server is a REST API that will manage a repository full of configuration. I'll go to start.spring.io, like so, and I'm going to build a simple config service like this. Config server, generate. I'm going to open this up in my IDE just as before. Okay, here we are. And I've got on my local desktop here a Git-based repository, right? So, oops. Okay, Git status. There it is. So there's a repository that I have on my GitHub that you can also get if you want for your examples later. There it is on GitHub, Josh Long, Bootiful Microservices config. But the point is it's managed by Git. So it's a bunch of files, right? Property files that I've got in a central folder. I'm going to now teach this config server where to find that repository. So I'll say spring cloud config server.git.uri equals home directory desktop config. Okay, whoops. And then I'm going to make this live on port 8888. Once I've done that, I'm going to go to config service application, and I'll say enable config server, and I'll restart this application. This is going to make it a configuration service that's going to babysit all those property files. My other microservices are going to connect to the config server. They're not going to read the information from the file system. We've created a little bit of an indirection. Okay, so if I am a microservice, if I'm a microservice and I want to see the properties for the name of the microservice called reservation service, here's what I would do. I'd go to localhost 8888/reservation-service/default, and you can see here that I've got two sets of property files. Reservation-service.properties, which has several properties, keys and values, and application.properties. All the microservices, no matter what their name, will see the properties in application.properties. Only the microservice called reservation service will see the properties in reservation service.properties. If there's a conflict, server.port versus server.port, then this value, because it's more specific, overrides the default in application.properties. Look also that I have a message. So we're going to teach our microservice, the reservation service, we're going to teach it to get its configuration from this config server. Okay? We're going to see that the application starts up on port 8000, and we're going to see that we have a message called hello world. So let's go back here to the reservation service. And you can see in the reservation service, I have Spring Cloud Starter config. This is the config client. Okay? And I'm going to go here, I'm going to say spring.application name equals reservation-service. And then I'm going to tell the REST API where to find the config server that we just created. Okay? So this information has to be read before the application is configured. So it's not appropriate to put it in application.properties. Instead, Spring Cloud expects this to be, by convention, in a text file called bootstrap.properties. Okay? So bootstrap.properties. And now, once I've done that, I can now take advantage of the keys and values in the config server. Let's go ahead and create a new REST controller here called message REST controller. And in that REST controller, I'm going to inject message, okay, string message, and I'll create a new endpoint here, request mapping, message, string get message, return this dot message. Now, I want to be able to change that message live without having to restart. So I'm going to annotate this component with @refresh_scope. Okay, so now let's go ahead and see if everything that we've just done has worked. First of all, we should see this application start on port 8000, not 8080, which is the default. Did it work? Did it work? Oh, the pressure. Yes, it worked. It worked. Good. So, localhost 8000/reservations, that's working, and message, that's working. But this is a terrible message. While it applies and it is technically okay, it's not really what we deserve or what we want. So I'm going to go back to the config server directory here, and I'll open up the reservation service.properties file here, and I'm going to change this message to say, days of Bucharest. And I'm going to add extra exclamation marks so that my opinion is more valid on Reddit. Okay, so there's that. Now I'm going to say git status. Okay, git commit -a-m YOLO. Okay, and you'll see that this doesn't see the value yet. Nothing has changed. But here it's immediately visible. The value is changed there. What I need to do is I need to tell Spring Cloud to redraw the configuration from the config server to see the new values. I can do this several ways by using an event bus, for example, but here I'm going to use the actuator endpoint, an endpoint that is exposed for operational purposes, to force this microservice to refresh itself. The endpoint, of course, very usefully, is called refresh. It's very refreshing. No? Okay, fine. So anyway, let's keep that on the top here like that, and we'll keep that down here, and go, and go. So there's the value, live and updated, right? I didn't have to restart the service. I just recreated that one variable, one property. So that's centralized configuration. It's very useful in a distributed system. I could lock this all down. I can do all sorts of things. I can do encryption of keys and values and so on, but we have to move on. So the next pattern that you're going to care about in a distributed system is the ability to discuss or to work with other services abstractly. I don't want to have to worry about where a service lives in order to be able to talk about it, to connect to it. Unfortunately, DNS is not a great fit in this case. We could use DNS, but it offers a few struggles, a few pains that we need to work around. First of all, if you're in a distributed system with a lot of dynamic components, DNS wants to be cached. It needs to be cached. So when you are trying to do a lot of things where DNS changes, it goes against the grain of the system. Also, DNS, at its best, if you use DNS, it has no way of answering questions for you. You can make a request to a DNS endpoint, which is mapped to a load balancer, and the load balancer may have 10 instances of the service, but if there are 0 instances, then your client is going to connect and it's going to hang. There's no response. It would be much better if I could ask the question, is there anybody there to respond to my request? And then not make the request at all if there are nobody there, right? So, for these reasons and more, we need something a little bit more dynamic and a little bit more client-centric, smart. So we're going to use something called a service registry. There are many implementations of service registries, and we support Apache Zookeeper, HashiCorp Console, etcd, and Netflix's Eureka. Okay, so let's go ahead and install a service registry. We're going to use Eureka in this case. I'm going to go to start.spring.io, and I'm going to use the Eureka server bit. I'm going to use the config client, and I'm going to name this the Eureka service. There we are. Good stuff. Okay, open, and I'll take some water. Okay, so Eureka service application, same as before, right? Same kind of approach. I need to have a bootstrap.properties, and I need to give it a name. So application.properties, spring.cloud.config.uri equals http localhost 8888, and I'm going to give it a name. So spring application name equals Eureka service. Got to rename the file. So bootstrap.properties, okay? And that should do. If I spin this up, I'll have a service registry. My memory's worse every day, but I think the port will be 8761. So localhost 8761. There we are. There's my service registry based on Netflix Eureka, right? And you can see that we have no services registered there yet. We cannot consume this service because nothing is registered. So what we're going to do is we're going to go back to the reservation service here and teach it how to talk to the service registry. We have Spring Cloud Starter Eureka here, but there are others, right? Zookeeper, Console, right? I mean, etcd is not there yet, but that'll be there soon. So there's these various options. Now, I need to opt into this. I need to actually say that I want to take advantage of Discovery Client support. So I'll say enable Discovery Client. Okay, there's this. And I'm going to restart. Okay, like so. And we should see very soon that service registered in our registry. But before that happens, let's look at building our first client. Is it there yet? Are you there yet? No? We're going to build our first client. We're going to say web. We're going to build you use a circuit breaker called Hystrix. We'll use the Zool microproxy. We're going to use the config client. We're going to use Eureka Service Registry and Discovery. We're going to use Zipkin for distributed tracing. And we're going to use Redis for messaging, okay? Just a few things. Okay, so here's that. And hit refresh, and you can see that the reservation service has been registered in Eureka, and it's available. There's the host and the IP and the port and all that, and it's available for discovery. There's only one instance registered right now, but we can add more, naturally. Now, let's go back to this client. This is going to be a service that talks to the reservation service via the registry. It's like all the other microservices. It needs to know where the config server is. So Spring Cloud config URI equals HTTP localhost 8888, and then we'll say spring.application.name equals reservation client. Okay, bootstrap.properties, and we're going to say reservation client application enable discovery client. Now, the first thing that we want to do in an edge service, this is an edge service. It's a client that's going to talk to the reservation service, but the edge service lives at the edge of the data center, at the edge of our cloud. It is going to handle requests from actual clients like iPhones and Androids and PlayStations and your HTML5 clients and your Rokus and your Xboxes and whatever, right? Your refrigerator, the Internet of Things, everything is a client now. And these clients have different security and payload and protocol requirements. You cannot change every microservice in your architecture each time you add a new HTML5 client or an iOS or Android or whatever. So you isolate those things, those client-specific concerns, in an edge service. The edge service can do certain kinds of things. Think about HTML5. HTML5 applications are very powerful. They have a lot of bandwidth, right? They're you've seen JavaScript. It's web browser scale. Now, this environment, while powerful, is sandboxed. I cannot make requests to many different services on different hosts and ports from within the confines of the JavaScript browser sandbox. So if I proxy my requests through a single host and port, then I can talk to them without running into trouble. I could, of course, add a policy to each of my microservices, a cross-origin policy, but then I would have to change every microservice just for a client. That's a terrible idea, right? So instead, I'll use a microproxy. There's one called Zool from Netflix. How many of you have heard of, or how many of you have kept up with your Greek and Ghostbusters mythology? So Zool, here we are. There he is. Oh, that's the gatekeeper to the underworld. He's the proxy to hell, okay? Now, if I go to localhost 9999 /reservation service /reservations, this is my edge service. This is the client. Remember that the actual service is here on port 8000. So there's there it is, my edge service on 9999. And you can see that the URLs have been rewritten because we proxy the headers and we send them back, and those are used to inform the URLs that have been written as well, right? This is very, very powerful. It means that if I have an HTML5 browser client, then if I have, if I want to talk to the reservation service, I just say reservation-service and then send the path. If I have another service called foo service, I say foo service, whatever, right? If I have a browser client, maybe this is enough. I just need to add HTTPS. I can add OAuth or HTTP basic. I'm done, right? That's enough to empower my client to talk to the backend suite of services. And they don't all have to live in a fat monolithic application. But if I want to do protocol or payload transformation or translation, I need something different. I need to process the requests as they come in and change them and change the replies that go out. This is called an API gateway. It's another kind of edge service. So we're going to go ahead and build a very simple, silly edge service, API gateway. I'm going to build a new controller here called Reservation API Gateway, REST controller, okay? And I'll say at AutoWired private REST template. So I'm going to use the REST template to make a REST call. This is an edge service, so I'm going to map it to value to reservations, right? And I'm going to map another endpoint here, public collection of string get, just to say reservation names, okay? And what I'm going to do is I'm going to return a subset of the data, a view on the actual reservation information. In this case, I don't want all of the hypermedia links. I just want the names. So what I'm going to do is I'm going to return the names here by doing some transformations on the data from the REST template. Before I can do that, though, we do need to ask ourselves a question, and I'm sure this has been making some of you a little confused. Which instance of the service is handling this request? I've only got one right now, but what if I had 10 in the registry? How does that work? Right now, this is the service ID. The micro proxy is calling the Eureka service registry. It's going to the registry and it's getting a collection, an array of all of the service instances, and then it's picking which one to use. This is not DNS. This is something called client-side load balancing. It's a component powered by Netflix Ribbon. Ribbon gives you the ability to make routing decisions, load balancing decisions in the client. So if I want to do data center aware load balancing, or if I want to do round robin, or if I want to do sticky sessions based on OAuth tokens or some business use case, maybe I have a customer that's logged in and he or she is looking at a streaming video on this particular node. That's not something you can just load balance transparently, right? Streaming video is a very stateful thing. I want to be able to pin that request to that node. All of these things are a little bit more complicated than the checkbox that most load balancers will have, for the simple options like round robin. So we have Ribbon in play. It's doing round robin load balancing by default, but it's just an object. You can override the bean that it's using and plug in your own. You can version control it, unit test it, and then evolve it as you need to for business use cases. So that's what's happening here. This is automatically being used for you by default. We're going to take advantage of that here as well. We're going to say, whenever somebody goes to request mapping equals get value equals names, so the aggregate URL is reservations /names, basically. That's the URL that you have to call to get to this endpoint. When that happens, we're going to say return this .rest template, rest template.exchange HTTP reservation-service /reservations. Now this is the service ID as well. This is not DNS. This is the registry ID. And it's automatically being processed for you in the REST template by an interceptor that Spring Cloud is contributing. I'm going to make it a GET call, and I'm not going to specify a body, so I'm going to say that. But I want to get the data that comes back from this, and I want to process it. How do I tell Spring what kind of object I want back? Remember, it's going to call this service, and it's going to get the JSON back. That JSON comes from Spring HotOS, and it's a collection of them. It's a resource with a payload whose payload is of type reservation. So what I would love to be able to say is, resources of reservation dot class. I wish I could say that, but Java doesn't have a type system, and so as a result, this doesn't work, right? There's a few things we need to do to make something like this possible. First of all, I need the Spring HardOS support on my client here, right? So I'm going to marshal, or unmarshal rather, the hypermedia payload from an envelope with a payload and links back into a Java object here, okay? So that's fine, but I still have the reservation. Where's this reservation going to come from? I don't want to keep the same jar on the server in my client. I don't want my client to be coupled to the types on the server. I know in this case that the server and the client are using Java, but in theory, and again, I've never actually seen this, it's just a theory that people say, in theory, that service could be written besides in something besides Spring and Java. Now, again, it's never actually happened. I'm not convinced it ever will, but it could, right? And so what I want to do is keep my client and my service decoupled. So I'm going to create a client-side representation here, right? So class reservation, string reservation name, and I'll say there's my getter, okay? Private, etc. And now, I still have another problem, which is that even though I have these types on the class path, this isn't valid syntax. Java doesn't keep generic information at runtime. If you have an instance variable like this, and you ask the instance variable, what is your generic parameter here? The parameter is string, t, right? T equals string. But that won't actually be there. If you use reflection at runtime, that'll say object. It's gone. It's burned away. So instead, what we need to say is, I need to say class x extends array list, right, of string. And now when I do that, I say class new x. There, that will work. At runtime, via reflection, the generic type of x is string. It's baked into the parent-child hierarchy. Java bakes it in only in subclassing. It doesn't do it for instance variables. So that's the hack that we had to make for Java 5 generics, right? So to support that, we need to capture generic information using type subclassing, which we can do using the type token pattern, like this. So resources of reservation ptr equals new parameterized type reference, like that, okay? There's our variable. And now notice that I had to subclass this. It's abstract. It won't let me not subclass it. Once I have that, though, I can say, what is your type? What's your class? And it'll give me a Java reflect type, which I can use to then tell this method what to do with the results that I get back from the JSON. I can tell it that I want a resources of reservation, okay? Once I have that, I can say response entity, give me the status code, the body, the headers. I want the body. I want the content, the collection of resources. I want to stream over it using Java 8 functional programming. I'm going to get the reservation and map it from a reservation to the reservation name. And I'm going to collect all the results in a list and then return that back to the client like so. So this will work. This will be a very simple edge service. I'm doing a little bit of a transformation, like that, okay? I'm going to do a very simple transformation, and really, these are complicated. These are 3 very complicated lines, but it's still just 3 lines, okay? Okay, so reservations, names. There's my list of names, right? That worked. We got the data back. But what happens if that service is not available? Right now, if there's 1 or more, then this will work. It'll load balance, and I'll get something from one of those nodes. But if there's 0 instances, I'm going to get a big fat stack trace in my iPhone, right? A Java stack trace in my iPhone. It's not a good experience, right? So what we need to do is to be a little bit more resilient. We need to be more resilient in the case of failure. When you move to a distributed systems world, you must assume that failure will happen, because it will. Right? So what we're going to do is we're going to build in a little bit of fault tolerance so that if something goes wrong, we'll have a fallback experience. Netflix and other big websites do this all the time. They'll say, oh, look, the search engine isn't working, but here are some recommendations. Right? You get something. It's not exactly what you wanted, but it's something. So I'm going to say fallback. And I'm going to, for now, I'll just return an empty array list. So I'll say there's that. And I'm going to use the circuit breaker. Now, a circuit breaker is a very simple design pattern. It's in a home, in a building. If you have too much electricity, the electricity flows through the circuits. If there's too much electricity, you risk having a fire. So the circuit breaker opens up and it stops the electricity from traveling. The immediate effect is that, of course, you lose the lights. But at least you have your house. You don't lose the house because of a fire, right? Much better. I would much prefer to gracefully degrade. My friend Chris Richardson talks about this all the time. He says, we as humans are resilient systems. We gracefully degrade. If you cut our finger, we don't blue screen, right? Very important. So we're going to do the same thing. So I'm going to build a fallback method here. I'm going to say @enable hystrix command, fallback method equals fallback. So if there's an exception in this method, if there's an exception thrown, this fallback method would be called and the result would be returned instead. Eventually, if I call that method too many times and I get no responses, it's going to not even try to call the service. It's just going to go immediately to the fallback. That gives my service that's fallen down some time to come back up, right? That helps you build a resilient system. Now, this is good for reading, but it's not good for writing, right? If I make a service call to the edge service and there's nothing on the other side to respond to the request, then I'm going to have trouble, right? I can't just drop writes to the database on the floor. I need to be more resilient. So I'm going to use eventual consistency. The idea here is that a service should use store and forward architecture, right? Basic messaging, basically. So I'm going to use something called Spring Cloud Stream. Spring Cloud Stream is an abstraction on top of Spring Integration. How many of you have heard of Spring Integration? Cool. So Spring Integration is a technology for building event-driven based and in messaging-based systems. Just like Spring MVC is a framework for building HTTP-based systems, right? 10. Yeah. Can I go like a little? Okay. Love you. Bye. Thanks. So we're going to use Spring Integration to handle stream processing. The idea is that I'm going to send a request to the edge service. The edge service is going to send a message to the service on the back end. If the service is available, great. It'll process the message and everything's going to be fine, just like if we had written it to the database directly. But if the service isn't available, it'll be stored in the broker, in the message queue. And you can use lots of different message queues. Right now, in the current milestones, we have Redis, Kafka, RabbitMQ, etc. So I've got Redis because it's lightweight, and I've got that running here. We're also adding JMS and Chronicle, and I think there's Aeron. I mean, we're adding more, right? But the point is, we want to be able to talk about other services abstractly, messaging-based microservices, with the same ease of use that we can talk about REST-based microservices. So I'm going to use Spring Cloud Starter Stream Redis, and I'm going to use Spring Cloud Stream's binding support. I'll say @enable binding. And I'll say that I want this client to produce messages. It's going to be a source. I can use any interface here. This is an interface that's in Spring Cloud, but it's a shortcut. You can do your own interface, right? If you have different services and you want to talk to them, you don't want to worry about where those things live. Imagine if I had a CRM. I could say output, message channel, orders, okay? And if I had another one called message channel customers, right? So again, all I care about is that I have these channels that connect to other services. A message channel is kind of like a Java util queue. You push and pop. What we don't want to worry about here is how this gets connected to a broker. That's configuration that lives outside of my Java app in the config server. And I'll show you that in a second. The benefit is that by declarative convention, Spring Cloud Stream is going to automatically hydrate or inflate or create these channels for us and do the wiring to connect them to other services based on the configuration. So I could say, instead of source, I could say CRM, and then as long as I had the right configuration, I could talk to two different downstream microservices. But since we're only doing one message out and we're going to do another message in on the other side, we'll just use the common default one called source, right? But again, just so you understand how that works. So now, once I've done that, I can build a new edge service, public void write request body reservation R, and I'm going to expose this as an endpoint method equals post, and I'm going to inject my channels, my message channels. So I'll say @autowired private source, okay? And here, this .source .output equals message channel. So there's my output channel, right? I can say output.send message builder with payload r.get reservation name .build. There we go. So all I'm doing is I'm sending a message. Where is that going to go? We don't know, but we'll see that in a second here, right? So localhost, you can see here that on the reservation client, I have Spring Cloud Stream bindings output equals reservations, right? I'm saying that the channel name is output, the message broker memory, the actual bytes, the buffer in the broker in Kafka and RabbitMQ, whatever, is called reservations. It's a destination, okay? On the opposite side, on the service that receives the message, I'm going to have the opposite, configuration. I'll say Spring Cloud Stream bindings input equals reservations, okay? So that's all we need to know for now, basically. Go to the reservation service here, and we'll do the same thing in reverse. We'll say @enable binding sync. So a source is like a faucet. It creates messages. It comes out of the faucet. A sink catches the messages. It receives them. Okay, and the sink has the reverse definition. It says subscribable channel input. Okay, so that's there. And now that we have this, we can use Spring integration to build some very basic messaging-based code. Integration component scan. We're going to build an endpoint here, class reservation processor. Okay. I'm going to say this is a service activator. So whenever a message comes in on this channel called sync, we're going to have this method, called accept new reservations string rn, and we're going to write the data to the database just as we would before. So @autowired private reservation repository, and there we are. And we'll say this dot reservation repository dot save new reservation rn. There we go. So I'm just going to write the data to the database eventually, right? If the service is down, then it'll be stored in the database, in the broker, in the message queue, and it'll be redelivered later. Okay, let's see. So there's this. I'm going to restart the service, and we should be able to restart the client. Is that right? Okay, there's that. Oop. Okay. Localhost, what do we say? Localhost 9999 reservation names. So there's the edge service. It's working for the read, but both systems are available. The producer and the consumer are available. I'm also going to go to Postman here, right? This is my little HTTP REST client that I'm going to use to send a post to the edge service to write the records. So I'll say, what's the new name? Somebody give me a name. What's your name? How do you spell it? Mary? Oh, I'm sorry. I'm trying. Gee. So there's the information. I'm going to send an HTTP post to that endpoint, okay? And there's the output, right? So I wrote the request to the edge service. It got delivered via Redis on the other side. Now, let's see if I go and kill the reservation service, this poor reservation service. Okay, it's going to hesitate at first because it's going to have an exception. It's going to hang and have an exception. But then we get the fallback method, an empty array list, not a stack trace, right? So we've built a system that is handling reads and writes gracefully. We have, hopefully you're using a cloud computing technology. Hopefully you're using something like a cloud. If you're using something like our Cloud Foundry or anything really, they will work day and night to make sure that if you say we need to have 10 instances of the application working, then there will be 10 instances of the application. You don't have to wear the pager. If something falls down, Cloud Foundry will pick it back up and make sure it's working. But it is our job as developers to build systems that do the right thing in the meantime. So the final thing that we're going to look at now that we've built robust systems, is how to build systems that are easy to see, to understand, to operationalize. We need visibility. Right now, we've got two very simple services, but imagine if you had more than a few. How do you correlate the flow of traffic from one component to another, to another, to another? You need distributed tracing. In theory, this is very simple. You create a UUID, propagate it in the headers, and then pass that header along to each message, to each service. But to do this requires a lot of instrumentation. You have to add code in the REST template, in the messaging, in the microproxy, in the MVC layer. Everywhere where a message can come in or go out, you have to make sure you have instrumentation to propagate this UUID. We have something called Spring Cloud Sleuth on the class path already. Spring Cloud Sleuth, a sleuth is a detective, looks for clues. Spring Cloud Sleuth has the idea of a span, which is the whole journey of a request, and then the trace, which is trace is the whole journey, and the span is each hop. If I go from service A to B to C, there are 3 spans, 1 trace. Okay? Spring Cloud Sleuth automatically collects that information for you. So here in the reservation client, for example, you can see it's being logged out. Here's the service ID, the trace, and then the span ID. And if you forward your logs to something like Elasticsearch or Splunk, then you can already do basic root cause analysis for errors and so on. But this information shouldn't be kept for more than a few days. This is operational telemetry data. It's not warehousing data, right? This is nice, but a picture is worth 1,000 words. So for this, we're going to use Twitter's Zipkin, right? You remember that I have Zipkin on the class path here. It says Spring Cloud Starter Zipkin. If I go now to my Zipkin instance running in my Docker image, but you can also use start.spring.io, you can see that I've got Zipkin running here. This is from Twitter. This is how they do distributed tracing. And I can go here, request reservation client, do a search, hit find traces. There's all of the, let's see, here's this one, expand all. So it says HTTP reservations names. It says that the whole request, for some reason, took this long. That's crazy. And then it went to the HTTP reservation service. And if I click on this, I can get the details on when it was made, the verb, the path, the URL, and so on. I get distributed tracing. I can now visualize through this waterfall graph how long each request took in each component and see if there's any errors. This gives me the ability to understand from a global perspective what my system is doing, not just individual services. This is useful, right? This tells a story about tracing. But the last thing we want to look at is recall that we have circuit breakers, and the circuits are wrapping potentially dangerous service-to-service calls. I'm going to go ahead and build in a dashboard so that I can see what these circuits are doing. You saw them in action, but I want to be able to visualize this. So I'm going to say Hystrix dashboard, config client, and I'll use the Eureka service registry to support. We're going to go ahead and hit Hystrix dashboard, open, and come on computer, faster. Hystrix dashboard, enable discovery client, enable Hystrix dashboard. We'll say application.properties, Spring application name, Hystrix dashboard, spring.cloud, config.uri equals HTTP localhost 8888, Alt F1, bootstrap.properties. Okay, and we should now be able to see this up and running on port 8010, I think, maybe, hopefully, sorta. Localhost 8010 Hystrix, there you go. So this is our Hystrix dashboard. What this thing is expecting is a stream of server-sent heartbeat events, right? Each circuit breaker provides that stream. So I can go to 9999 hystrix.stream, and you can see that this never ends. Do not curl this, okay? So I can now take this and then paste this here, right? Hit monitor. And now, let me grab another endpoint, localhost 9999/reservations names. There's the data over there. Oops. So now, if I make requests on the left, you can see the traffic is going up on the right, trending ever upward as I make requests, so 5, 26, whatever. The circuit is closed, of course, so you can see everything is fine, no failures, 0% failures. But what happens if I go and kill the service, the reservation service? Again, poor thing, right? So here's this. Oops, wrong one. Reservation service. If I kill this, it's going to try to connect, but it'll fail, right? 100% failure. I'm making requests, and of course you can see it's still hesitating on the left, but eventually it's going to just go straight to the fallback. And in the meantime, there we go. Now it's just going straight to the fallback. I'm not even waiting. It's going always to the fallback. It's giving my service downstream time to recover, and in the meantime, I can visualize that that system is down. So we've taken a very short trip through just a few of the things that Spring Boot and Spring Cloud can do. We've looked at how to build a very simple API, a REST API, a self-describing API using hypermedia. We've looked at centralized configuration. We've looked at service registration and discovery. We've looked at how to build resilient systems by using things like circuit breakers and messaging for eventual consistency. We've also looked at operational concerns like distributed tracing and the circuit breaker dashboard. I feel like we didn't really have a lot of time, and if we did, we could have covered some stuff, but we didn't have the ability to really, we didn't get to look at much, and I'm sorry about that, but there's just not much I can do, you know? Maybe next time we'll have some more time to look at some real stuff, okay? Now, I want you to please recall that there's a lot more here. Like if you want to do centralized single sign-on, cloud security, you want to protect all of your microservices and use an OAuth token, there's support for that. If you want to do cluster management with master leader, leadership election and all that stuff, there's support for that. A cloud-native application is one that is distributed and is optimized for continuous and safe delivery of value into the customer in production. I appreciate that you spent this time with me. Merci, thank you so much, everybody. I appreciate it. If you have questions, josh@joshlong.com. Thank you, Mark, for this amazing show. And thank you, Alex, and everybody else from the team. You guys like that, maybe?
Hello, I'm just going to steal Josh's headset for 1 second. So we've come to the end of the day, and thanks, Josh. Amazing speaker, yeah? So there's just a couple of things to tell you. Firstly, I want to say thank you to these guys, because these guys have been awesome. I said it this morning, but hey. Now that we're closing up, when you leave, please go, well, firstly, get your bags and your coats and stuff. That's bad if you leave without that, but get your t-shirt as well. So there's t-shirts outside. From here, we go to somewhere that I can't pronounce, and so...
It's Beredia Hash, and also...
Exactly.
And also, thank you, Mark, for helping us doing this great event. So.
And actually, there's one last thanks to do, which is to you guys, because without you and your passion and the fact that you want to come and learn, there's no point in doing this. So do it again. Encourage these guys to make it bigger, better, if it's possible. Have more amazing speakers like Josh, but not like...
Better, much better.
Josh, hang on. I've got to take Josh to task here.
I started with the talk. Did I not talk about this?
Yeah. Okay.
I did. I started it. I said I love this shirt and I should have worn it.
Earlier today, he basically said, "I'm going to do a strip. Yeah, I'm going to strip off. I'm going to say I can't continue to do this without the amazing Vox Days Bucharest T-shirt on." But I'm disappointed. Hey, it's fine. But look, seriously, thank you. Keep up the great work and give these guys feedback because it's really important.
Thank you.
Enjoy. Bye bye.